Tonight, we journey beyond the edge of everything you've ever known, beyond the familiar constellations that dot your night sky, beyond even the most distant galaxies your mind has ever tried to imagine. We are going to travel together into a place where time itself begins to lose meaning, where the rules that govern our everyday world seem almost quaint compared to the cosmic mysteries waiting in the darkness. And what we discover there? What the James Webb Space Telescope has revealed to us in the silence of deep space. It will change forever the way you think about your place in this universe. Close your eyes for a moment, if you'd like. There's no rush. This journey we're about to take doesn't require haste. It requires only your gentle attention and your willingness to drift, slowly, into wonder. We'll explore together, at your pace, in the quiet hours when the world feels still and the universe seems closer than ever before. If you're the kind of person who lies awake at night, wondering about the cosmos, who feels that strange pull when you look up at the stars, who wants to understand the deepest mysteries of existence while your mind settles into the peace of approaching sleep, then you've found exactly where you need to be right now. And if you haven't yet subscribed to this channel, there's something special waiting for you here. But for now, let's begin where all great journeys must begin, with a question that has haunted humanity since we first looked up at the night sky and wondered, what lies beyond what we can see? Imagine, if you will, a moment in human history. A moment not so long ago, just a few years back, really, though it feels like a lifetime has passed since then. Scientists, engineers, and dreamers had spent decades working toward a single goal. They had imagined, designed, built, and launched an instrument so powerful, so delicate, so impossibly complex that its success seemed almost miraculous. This wasn't just another telescope pointed at the sky. This was humanity's way of reaching back through time itself. The James Webb Space Telescope. You may have heard of it. You may have seen images from it, those stunning photographs of nebulae and galaxies painted in infrared light, impossibly beautiful and strangely haunting. But here's what most people don't fully understand, and this is where our journey truly begins. This telescope wasn't just meant to look at pretty things in space. It was designed with a singular, profound purpose: to see farther back in time than any human instrument had ever seen before, to witness the universe as it was just a few 100 million years after the Big Bang itself. And as it turned its mirror toward the cosmos and began to collect ancient light that had been traveling through the void for over 13 billion years, something happened. Something that wasn't entirely expected. Something that made scientists pause, reconsider, and ultimately realize that our understanding of how the universe works might need to be fundamentally rethought. But there's more to this story. Far more, because the shocking discoveries didn't come all at once. They came in waves, layer upon layer of mystery, each one revealing something about the universe that seemed to contradict what we thought we knew. And the deeper we looked, the stranger everything became. Let me paint a picture for you. Imagine you're standing at the edge of a vast ocean in the hours before dawn. The world is quiet. The stars are still visible, though they're beginning to fade as the first hints of morning approach. You can't see very far into the darkness, maybe just the immediate shoreline, where the waves lap gently against the sand. But then, someone hands you a pair of binoculars, powerful binoculars. And you look out, and suddenly you can see across the entire ocean, impossibly far. And on the far shore, you see cities, civilizations, structures of such magnificent complexity that your mind struggles to process what you're witnessing. That's what happened when the James Webb Space Telescope opened its eyes. We thought we understood the early universe. We had spent decades developing theories, running simulations, creating mathematical models of how galaxies should form in those first moments after creation. We had a story, a narrative that made sense, that felt complete. Galaxies started small, we thought. In the earliest universe, only small structures existed. They collided, merged, grew larger over billions of years. And eventually, through this patient process of cosmic construction, they became the massive galaxies we see today. It's a beautiful story, logical, elegant, and as it turns out, completely wrong, or at least not entirely correct, which might be even more unsettling, because a theory that's partially wrong is more dangerous than one that's completely wrong. Partially wrong theory can hide the truth better. It can convince us we understand something when we don't, at all. When the James Webb began to image the deepest reaches of space, it found something that made astronomers sit up in their seats and rub their eyes, wondering if they were reading the data correctly. Fully formed, enormous galaxies. Not small proto-galaxies, not the simple building blocks of the cosmos, but massive, sprawling structures with hundreds of billions of stars appearing in the very early universe. Appearing where, according to every model we had, such galaxies simply couldn't exist yet. It was like looking for tadpoles at the beginning of the world's history, and instead finding adult frogs already established and thriving. And this is where the universe begins to become truly mysterious. Because if these galaxies existed so early, if they were so large so soon, then everything we thought we knew about how the universe formed needs to be questioned. The timeline is wrong. The mechanisms are wrong. Something fundamental, something we had confidently built our understanding upon, is wrong. But hold on, there's more. There's always more when you start pulling at the threads of cosmic mystery. Slowly, as the James Webb collected more and more light from the ancient universe, more and more impossibilities began to surface. Structures appeared that shouldn't exist. Patterns emerged that couldn't exist according to our theories. Black holes appeared in the early universe, behemoth objects of such immense gravity that they seem to have come into being in ways we don't yet understand. Stars formed in regions of space where star formation should have been nearly impossible. The more we looked, the more we realized we had been peering at the universe through a lens that was fundamentally distorted. And yet, as strange as all of this is, there's a deeper strangeness still, a more profound mystery, one that touches on the very nature of reality itself, one that suggests something even more fundamental might be wrong with our understanding of physics, of time, of how the universe came into being. Imagine you've spent your entire life inside a house with no windows. You've developed an elaborate theory about what the world outside must be like, based on what you can hear, what you can infer from the sounds and sensations around you. Your theory is detailed. It's logical. It makes sense given the information available to you. But then one day, the walls come down, and you step outside, and the real world is nothing like what you imagined, not just different in small ways. Fundamentally, profoundly different. That's where we are now. The walls have come down. The James Webb has opened a window to the ancient universe that we've never had before. And what we're seeing outside doesn't match the theories we spent decades constructing. And here's the thing that makes it truly breathtaking. We're only at the beginning. We've barely started to understand what these discoveries mean. The data is still being analyzed. The images keep coming. And with each new observation, each new deep field image, each new spectroscopic reading, more questions emerge, more mysteries unfold. The universe, it seems, is far more complex, far more strange, far more wondrous than we ever dared to imagine. But before we dive deeper into these mysteries, before we begin to explore the specific discoveries that are reshaping our understanding of the cosmos, we need to understand what it means to see back in time. We need to grasp, in your bones and in your spirit, what it means that light traveling across the universe is also traveling backward through history. Because this is the secret that makes the James Webb's discoveries possible. This is the mechanism by which we can witness the universe's infancy from our position billions of years in the future. Think about what light is for a moment. Not the scientific definition, though that's interesting too. But think about what light means to you. When you see the sun, you're not seeing the sun as it is right now. You're seeing the sun as it was 8 minutes ago, because that's how long it takes for light to travel from the sun to your eye. Those 8 minutes might seem insignificant in the grand scheme of things, but the principle is universal and unchanging. Light is the ultimate historian of the universe. It carries information about distant events, and that information travels to us at a constant, measurable speed. Now, imagine extending that principle across billions of years. Imagine light that has been traveling through empty space since the universe was young. Light that left distant galaxies when those galaxies were only a few 100 million years old. Light that has been journeying toward us through the expanding fabric of space itself for over 13 billion years. When that light finally reaches our instruments, when it reaches the James Webb, we're not just looking at distant objects. We're looking at history. We're witnessing a moment in cosmic time that played out when your planet didn't exist, when your sun hadn't even been born, when the universe itself was still in its infancy. And so when we look at those distant, ancient galaxies through the James Webb's infrared eyes, we're not just seeing the way they look today. We're seeing them as they were billions of years ago. We're peering into the universe's deep past. We're reading the autobiography of creation, written in light and distributed across the cosmos. This is why the discoveries are so shocking. Not because they're surprising in an entertainment sense, the way a plot twist in a movie might surprise you, but because they contradict the fundamental narrative we had written about how the universe came to be. They suggest that the story is much more complex, much more intricate, much more filled with unexpected turns and mysterious mechanisms than we ever suspected. And yet, there's something almost beautiful about being wrong in this way. There's something peaceful about discovering that you've misunderstood something profound, because that discovery also means you're about to learn something new. The universe, in its infinite complexity, is handing you a gift. It's offering you the opportunity to expand your understanding, to grow your mind, to become more fully aware of the wonders that surround you, and extend infinitely outward in all directions. So let us settle in together for what comes next. Let us drift deeper into the mystery. Let us explore not just what the James Webb found, but what those findings mean for your understanding of reality itself. And let us do so gently, slowly, at a pace that allows you to contemplate and dream and wonder, even as your eyelids grow heavy and your thoughts begin to drift toward the peaceful shores of sleep. Because that is the real journey we're on tonight. We're not just learning about astronomy. We're learning how to be comfortable with mystery, how to sit with the unknown without fear, how to let wonder transform into peace. And perhaps, in the process, we'll all fall asleep a little bit easier, knowing that we live in a universe far more magnificent, far more strange, and far more beautiful than we could have possibly imagined. The night is still young. The stars are waiting. And there are so many mysteries yet to explore. And yet, before we can truly understand what makes these discoveries so profound, we need to step back into a time that predates even the James Webb itself. We need to travel back through the history of how humanity learned to see. For thousands of years, we only had our eyes. We stood in fields and deserts and mountains, and we looked up at the night sky with nothing but our naked vision to aid us. And in that darkness, we invented stories. We saw patterns in the stars and gave them names. We created constellations and myths. We imagined that the stars were windows into another realm, another reality far removed from our own. And in a way, we were right. But our imaginations, as creative as they were, couldn't truly grasp the scale of what was actually there. Then, about 400 years ago, someone pointed a simple tube with lenses at the sky, and everything changed. Galileo's telescope. A primitive instrument by modern standards, yet it transformed our understanding entirely. Suddenly, there were stars we hadn't seen before, moons around Jupiter, mountains on our own moon. The universe became larger, more complex, more filled with previously invisible wonders. But even Galileo, even with his revolutionary tool, was still working with visible light, the light our eyes can see, the narrow band of the electromagnetic spectrum that our human biology happens to be sensitive to. And while visible light is beautiful, it is also incredibly limited. It's like trying to understand an entire orchestra by listening only to the violin section. You're missing so much. Over the centuries, as technology advanced, scientists developed instruments to see beyond visible light. They built telescopes that could detect infrared radiation, ultraviolet radiation, X-rays, gamma rays, radio waves. Each new window into the electromagnetic spectrum opened up an entirely new view of the universe. It was like discovering that the world wasn't just three-dimensional, but had hidden dimensions layered beneath and above. Each new instrument was a key that unlocked a door to a different version of reality. And then came the Hubble Space Telescope. Launched in 1990, it orbited above the atmosphere, free from the distortion that Earth's air creates. It could see farther, clearer, deeper than any telescope before it. And for 30 years, it was the crown jewel of cosmic observation. It redefined what we thought we knew about the universe. It showed us galaxies in the deep field that would have seemed impossible before. It measured the rate at which the universe was expanding and revealed the existence of dark energy. It was a revolutionary instrument. But Hubble looked primarily in visible light and ultraviolet. It could see the universe's structure, but there were regions it couldn't fully penetrate, dust clouds that scattered its light. Distant galaxies, whose light had been stretched so far by the expanding universe that it had redshifted into the infrared frequencies beyond what Hubble could clearly detect. So scientists dreamed of something better, something more powerful, something that could see in infrared, that could penetrate through dust, that could detect the light from galaxies that were so far away, so long ago, that their visible light had been shifted completely out of Hubble's range. And in December 2021, after decades of planning, countless setbacks, and nearly $1 trillion in development costs, they launched it, the James Webb Space Telescope. Named after a former NASA administrator, this instrument was unlike anything humanity had ever attempted to build. It had to be unfolded in space, piece by piece, as it traveled 1 million miles from Earth to a special point in space called the Lagrange Point 2, where the gravity of Earth and Sun balance perfectly, allowing an object to remain stationary relative to both. It was fragile. It was complex. It was almost impossibly beautiful in its engineering. And when it finally opened its mirror to the universe and began collecting light, the data started flowing back to Earth in streams that would fundamentally change astronomy forever. Now, imagine you're sitting in a quiet room, a very quiet room, the kind of room where, if you listen closely enough, you can almost hear the absence of sound. This is the kind of quiet that the infrared wavelengths operate in, not literally quiet, because light isn't sound, but metaphorically quiet. Infrared is the light of heat, of warm objects, of the radiation that objects emit not because they're glowing visibly, but because they have warmth. It's the light you might imagine if the universe had a temperature and was trying to express it through radiation. And this is exactly what makes it so perfect for seeing the early universe. You see, when the Big Bang happened, and we should talk about what we think that means, the early universe was incredibly hot, unimaginably hot, the kind of temperature that no furnace on Earth could replicate. In those early moments, there was no light as we typically understand it. There was only energy and particles. But as the universe expanded, it cooled. And as it cooled, light was born, the first light in the universe. And this light, this primordial light, has been traveling toward us ever since, gradually cooling and losing energy as the universe itself expanded around it. This ancient light, we call it the cosmic microwave background, and it fills the entire universe. Every direction you look, if you had an infrared detector sensitive enough, you would see this faint glow, this echo of the universe's infancy, this oldest light available to our observation. But the James Webb, doesn't just detect this background radiation. It looks beyond it into the first galaxies that formed. And here's where things get genuinely strange. Think of it this way. Imagine you're in a library that contains the complete history of your family. Every document, every photograph, every letter ever written. And imagine that the documents are arranged in chronological order, going backward in time. So at the front of the library is yesterday's mail. As you walk deeper into the library, you find older and older documents. The further back you go, the older the documents. Eventually, you reach the very back, the very depths of the library. And there, you expect to find simple documents. A birth certificate, maybe a few early records. Simple, primitive things, because this was long ago, when written records were rare and technology was minimal. But instead, you find a library. A complete library of its own. Elaborate, complex, filled with countless volumes, organized perfectly, and seemingly impossible to have been created so long ago. That's what the James Webb found when it looked at the early universe. The galaxies there shouldn't exist. Not yet. There wasn't enough time for them to form through the mechanisms we understood. And yet there they are. Enormous structures. Billions of stars each. Complex structures with spinning disks and spiral arms. The universe, it seems, had a shortcut. A way to build these massive structures in a fraction of the time that our models predicted should be necessary. And with each image, with each data point collected, the mystery deepened. Because it wasn't just that the galaxies were larger than expected. It was that they were more numerous than expected, more complex than expected, more beautiful, in their strange alien way, than anyone had imagined they could be. Slowly, gradually, the implications began to sink in. Something was fundamentally wrong with the models. The physics might be incomplete. There might be mechanisms at work in the early universe that we didn't understand. Processes that allowed galaxy formation to happen faster, more efficiently, more spectacularly than our current theories could account for. And this was only the beginning. Because as the James Webb continued to look deeper, continued to collect more data, more mysteries emerged, like patterns appearing in static, like an image slowly coming into focus. And that image showed a universe far more complex, far more wondrous than we had ever imagined. Let your mind drift now, slowly, into what it means to truly be ancient. Not ancient like a building that's 1,000 years old. Not ancient like the pyramids or the oldest civilizations we know of, but ancient in the cosmic sense. Ancient like 13 billion years. Ancient like the age of the universe, divided by 10. Ancient enough that everything you've ever known, every accomplishment of human civilization, every star you can see in the night sky with your naked eye, would not yet exist. In the early universe, just a few 100 million years after the Big Bang, space was filled with a substance that was hot and dense and charged with energy. Stars were forming for the first time. Massive stars, many of them short-lived, burning bright and burning fast. And the light from these first generations of stars was beginning to travel outward, to journey across space, to eventually, billions of years later, reach our instruments. This is where the real shock of the James Webb's discoveries begins to crystallize. Because not only were galaxies forming early, but they were forming in ways that shouldn't have been possible. And this requires us to understand something about gravity, about the nature of how structures form in the universe. Imagine a vast, uniform ocean. The water is perfectly still, perfectly smooth. Now imagine that you begin to very, very slightly disturb that surface in certain locations. Infinitesimal ripples. The kind of disturbance that would be almost impossible to measure. But gravity is patient. Over billions of years, those tiny disturbances grow. They attract more matter. They become denser. They begin to collapse in on themselves. And from these collapses, structures emerge. Stars, galaxies, the organized complexity of the universe. The earlier in the universe's history this process begins, the more time there is for these structures to grow. But there's a limit, a cosmic speed limit, so to speak. You can't build enormous, complex galaxies instantaneously. Even with billions of years, there are limits to how quickly matter can accumulate, how fast a structure can form, how massive a galaxy can become. But the James Webb found structures that seem to violate these limits. Galaxies of incredible mass and complexity, appearing in the early universe before, statistically speaking, there should have been enough time for them to form. It was as if the universe had broken its own speed limit. And this finding rippled through the astronomical community like a shock wave through a pond. And yet, there's something even more puzzling, more strange, more impossible. You see, when we look at these ancient galaxies, we find something unexpected in their structure. Some of them appear to have the signatures of mature galaxies. They have rotating disks, like spiral galaxies. They have evidence of multiple generations of stars. They seem settled, established, as if they've been around for a very long time already. But there hasn't been a very long time. Not yet. The universe is still young, still in its infancy, still shaping itself. And yet these galaxies look like they've been here forever. It's as if you found a child who, despite being only 5 years old, had the wisdom and composure and physical maturity of a 50-year-old. It defies our understanding of how things should develop. It suggests that either our understanding is incomplete, or something very unusual happened very early in the universe's history. And this is where things become philosophically interesting, because science is ultimately about understanding reality, but reality has a way of being far stranger than our intuitions suggest. The universe, it turns out, doesn't care about our expectations. It doesn't care that we thought things would take longer. It doesn't care about our models and our calculations. It simply is what it is, regardless of whether we understand it or not. So the James Webb kept looking, kept collecting data, kept revealing galaxy after galaxy that seemed to contradict the accepted models. And slowly, the astronomical community had to acknowledge something that is simultaneously terrifying and exhilarating for any scientist. There was something fundamentally wrong with their understanding. But hold on, because the mysteries don't stop with just the galaxies themselves. No, the deepest shock came when scientists began to examine what was hiding inside some of these ancient galaxies. What was powering them? What was making them shine? In every galaxy, at its core, there should be a black hole. We've known this for some time. Our own Milky Way has a supermassive black hole at its center. It's a point of infinite density, infinite gravity, a place where space-time itself is so warped that nothing can escape from it, not even light. And these black holes come in different sizes. Some are small, formed from the collapse of individual massive stars. Others are supermassive, millions or billions of times the mass of our sun. The origin of these supermassive black holes has been a mystery. How did they grow so massive? In our galaxy, our black hole has had 13 billion years to accumulate material, to grow, to reach its current mass of about 4 million suns. Given enough time and enough material, you could imagine a black hole growing to be supermassive. But remember those ancient galaxies that James Webb found, the ones that appeared far too early, far too large. Well, inside some of them, the James Webb detected quasars. Quasars are some of the brightest objects in the universe. They're powered by material swirling around supermassive black holes, spiraling downward, releasing incredible amounts of energy as they do. And these quasars existed in the early universe. Very early, billions of years earlier than we would have expected, which means the supermassive black holes they contained had already grown to be billions of times the mass of the sun, in less time than should be possible, according to our current understanding of how black holes can feed and grow. Let that sink in. Picture a black hole, not a small one. A black hole so massive that it contains more material than your sun and 4 million others combined. Now imagine it being even larger, 1 billion times larger than that. Picture the gravitational field around it, so intense that space and time themselves are warped beyond recognition. Picture the event horizon, that point of no return, stretched across millions of miles. Now imagine that this impossibly massive object didn't have 13 billion years to grow. It had only a few 100 million years. It had to grow faster, accumulate matter faster, become heavier faster than anything in our understanding of physics would allow. And yet, there it is, detected by the James Webb, existing, real, a puzzle wrapped inside a mystery, defying explanation. This is where the universe begins to reveal its true nature, not as something that conforms nicely to our theories, but as something that is willing to shatter them entirely, to remake our understanding from the ground up. And this, oddly enough, is beautiful, because it means that reality is stranger and more wonderful than we ever imagined. The night deepens now, as we dive deeper still into mystery. And with each layer we peel back, each impossibility we encounter, the universe seems to grow darker and more vast, more complex, more filled with secrets that our science is only beginning to glimpse. But wait, the mysteries continue to unfold, don't they? There's a rhythm to discovery, a pattern to how the universe reveals its secrets. First comes the observation, the unexpected data point. Then comes confusion. How can this be? What have we misunderstood? And then slowly, a realization begins to dawn. Perhaps the problem isn't with the universe. Perhaps the problem is with our assumptions. And this brings us to one of the most profound revelations that the James Webb has given us. A discovery that doesn't just affect our understanding of galaxies, or black holes, or even the early universe. A discovery that touches on the fundamental nature of reality itself. We need to talk about expansion. Now, most people have heard that the universe is expanding. It's become a common piece of knowledge, the kind of thing that shows up in articles and documentaries and casual conversations about space. The universe is expanding. It's in every major media outlet. It's taught in schools. And yet, I wonder if the full implications of this statement have truly sunk in. If you really, truly understand what it means. Let's imagine together, shall we? Imagine a balloon. A simple balloon, the kind children play with. It's deflated, lying flat, almost invisible. Now imagine that this balloon represents all of space, all the universe. Now imagine someone begins to blow air into it. As they do, the balloon expands. It grows larger. And as it grows, if you had placed dots on the surface of the balloon, representing galaxies, or clusters of galaxies, those dots would move farther apart from each other. They're not moving through space. They're not traveling across the balloon's surface in the traditional sense. Instead, space itself is expanding around them, carrying them apart. This is what we mean when we say the universe is expanding. Galaxies aren't flying away from each other through empty space. Rather, the space between them is increasing. The universe itself is growing. Now, here's where it gets interesting. And this is where the James Webb's discoveries take on a new dimension of strangeness. If the universe is expanding now, and if you run that expansion backward through time, you would reach a point where everything was much closer together, where all the matter of the universe was compressed into an infinitely small point. And from that point, at a specific moment in time, everything emerged. The Big Bang, the beginning. We've known this for decades. We've built our understanding of cosmology on this foundation. The universe had a beginning. It expanded from that beginning. It continues to expand. This narrative has shaped our entire understanding of cosmic history. But here's what the James Webb has suggested, and this is where things become truly disorienting. Perhaps the expansion isn't what we thought it was. Perhaps the universe is expanding faster than our models predicted. Perhaps it has always been expanding faster than we realized. And if that's the case, then the early universe, the universe when galaxies were forming, would have been different than we imagined. Think about it. If the universe was expanding faster than we thought, then things that are now very far apart would have been closer together before. Matter would have been denser earlier. And if matter was denser, if things were closer together in that crucial period when the first galaxies were forming, then perhaps it's not so mysterious that galaxies formed quickly. Perhaps it's not so strange that supermassive black holes grew so rapidly. Perhaps the timeline makes more sense if we adjust our understanding of how fast the universe was expanding. Or at least, that's one possibility. But here's the troubling part. When we look at the measurements, when we examine the data that the James Webb has collected, there are hints that something else might be going on. Something that challenges an even more fundamental aspect of our understanding. You see, there's a number that astronomers care about deeply. They call it the Hubble constant. It's a measure of how fast the universe is expanding right now. And this number is incredibly important because it tells us about the age of the universe, about how much time has passed since the Big Bang, about the entire trajectory of cosmic history. The problem is, we keep measuring it and getting different answers depending on the method we use. When we measure it one way, using nearby galaxies and a certain method of calculation, we get one value. When we measure it another way, using the cosmic microwave background in different calculations, we get a different value. The difference isn't huge, but it's real. It's statistically significant. And in a field as precise as cosmology, any discrepancy is deeply troubling. It's like if you asked 10 different people to measure the height of a building, and 5 of them said it was 1,000 feet tall, but 5 others said it was 1,050 feet tall. The difference is small, but it's real, and it suggests that something is wrong. Either the building is changing height, or there's something about the way we're measuring it that we don't understand. And this discrepancy, this tension between different measurements, becomes even more interesting when we consider what the James Webb data suggests. Because those ancient galaxies, those impossible structures, those black holes that grew too fast, they might be evidence that the expansion was different than we measured, that the universe was expanding faster back then, or at a different rate, or in a way that our current models don't account for. And if that's true, then something in our understanding of physics real, fundamental, deep physics needs to be adjusted. Because the expansion of the universe isn't just a cute fact about astronomy. It's connected to everything. It's connected to gravity, to the nature of space-time, to the laws that govern the behavior of matter and energy. So here we are, standing on a threshold. The James Webb has given us eyes to see deeper into the universe than ever before. And what we've seen is that our understanding is incomplete. It's not just incomplete in small ways. It might be incomplete in fundamental ways. And that realization is both terrifying and exhilarating. Because this is what science really is. This is the moment when we realize that the house we built, the theoretical structure we constructed with such care and precision, might have a flaw in its foundation. And that flaw, once we understand it, will lead us to an understanding that's deeper, truer, more aligned with reality. Your eyes are probably growing heavier now. Your mind is probably beginning to drift. And that's perfect. Because as you drift, we drift together into deeper waters. Darker waters. Waters where the mysteries run deeper still. Slowly, gently, let yourself sink deeper. Imagine that you're floating in space now. Weightless. Drifting. The stars are all around you, stretching in every direction, infinite and eternal. Some are near, bright and intense. Others are far, dim and distant. And you realize, as you float there, that each one of those distant stars is actually a galaxy. Each tiny point of light is a city of stars, a vast civilization of suns and planets. And those galaxies stretch so far away that the light from them takes billions of years to reach you. Now imagine that you're slowly, gradually, falling backward through time. The galaxies around you are aging in reverse. Stars are dying, then reversing, then becoming brighter again. The light from distant galaxies seems to be getting younger, older, stranger. And you realize that you're not just falling backward through space. You're falling backward through history. You're witnessing the universe as it was billions of years ago. This is the journey that the James Webb has allowed us to take. And what we've discovered along the way has profound implications for something very basic, something we thought we had figured out, the age of the universe itself. We have a number for this: 13.8 billion years, give or take 100 million or so. This is the age of the universe, measured from the Big Bang to now. We've known this number for a couple of decades now, and it's been refined over time as our measurements have gotten better. It's based on careful observations of the cosmic microwave background, that ancient light we talked about earlier, and on measurements of the expansion rate. And for a long time, this number was solid. It was settled. We knew the universe was about 13.8 billion years old, and we built our entire understanding of cosmic history on that foundation. We calculated when stars formed, when galaxies formed, when black holes formed. Everything fit neatly into this timeline. Everything made sense. But then the James Webb started finding things that shouldn't exist in this timeline. And the implications are subtle, but profound. You see, if the universe is 13.8 billion years old, and we're observing galaxies that exist when the universe is only a few hundred million years old, then we have a specific amount of time available for galaxy formation. 500 million years. A billion years. The exact number depends on which ancient galaxy we're talking about, but the principle is the same. There's only so much time available. And in that time, the universe had to do a lot of forming. But what if the universe is older than we think? What if it's actually 14 billion years old, or 14.5 billion years old? A seemingly small change, just a few hundred million or a billion years difference, would actually provide a lot more time for these galaxies to form. It would ease the pressure on the timeline. It would make the mysteries slightly less mysterious. And here's what's genuinely interesting. There are hints in the data that the James Webb has collected that this might be true. There are faint suggestions that the universe might be older than our current measurements suggest. Not dramatically older, but noticeably older. How could this be? How could we be wrong about something so fundamental, so well measured, so supposedly settled? The answer lies in the nature of cosmological measurements and the assumptions that underlie them. You see, when we measure the age of the universe, we're not directly measuring time, the way you might measure it with a clock. Instead, we're measuring expansion. We're looking at how fast the universe is expanding now, and we're assuming that it has always expanded at a certain rate. We run the expansion backward and see how long it would take to reach the point where everything was compressed into a single point. That's how old the universe is. But this calculation depends on assumptions about what the universe is made of, about how dark matter behaves, about how dark energy works. And what if those assumptions are slightly wrong? What if dark energy, that mysterious force that's accelerating the expansion, works slightly differently than we think? What if dark matter, the invisible substance that makes up most of the matter in the universe, is distributed slightly differently than our models suggest? Small changes in these assumptions could lead to small changes in the calculated age of the universe. And suddenly, the timeline expands. Suddenly, there's more time for the early universe to do what it needs to do. Suddenly, some of the mysteries become slightly less mysterious. But here's the deeper insight, and this is where we enter truly philosophical territory. Even if the universe is older than we think, even if we adjust our measurements and expand our timeline by a few hundred million years, we still haven't solved the core mystery. We've just pushed it back a bit. The fundamental question remains: how did the universe create structure so quickly? How did matter organize itself into galaxies so efficiently? What mechanisms were at work in the early universe that allowed such rapid, efficient creation? And this question touches on something even more profound. It touches on the very nature of causation and time. It touches on whether the universe is fundamentally random, or whether it operates according to some kind of deep order or pattern that we don't yet understand. It touches on the question of whether reality itself has an intentional structure, or whether it simply emerges from the interplay of random quantum events. Now, we should be careful here. We should be careful about reading too much into scientific mysteries. We should be careful about letting our philosophical inclinations color our interpretation of data. But we should also be open to the possibility that the universe is weirder, stranger, more beautiful than our current theories suggest. Because that has been the history of science. We've repeatedly discovered that reality is far more complex, far more intricate, far more filled with hidden structure than we previously imagined. Think about how many times this has happened. Galileo looked at the sky and found moons orbiting Jupiter. People assumed the Earth was the center of everything, and suddenly it wasn't. Newton discovered gravity, and suddenly the motion of planets made sense. But then Einstein came along and revealed that gravity wasn't a force pulling on objects. It was the curvature of space-time itself. A completely different picture of reality. And then quantum mechanics came along and revealed that at the smallest scales, reality behaves in ways that defy intuition. Particles can be in multiple places at once. Observation affects reality. Certainty gives way to probability. Each time, our understanding deepened. Each time, we discovered that reality was more complex, not less. And there's no reason to think this pattern will stop. There's no reason to think that the James Webb's discoveries will be the last time we have to revise our understanding of the universe. And so as you drift here, floating in the darkness, surrounded by ancient light and distant mysteries, allow yourself to rest in this uncertainty. Allow yourself to accept that there is much we don't know, that the universe is vast, constrained, and filled with secrets that will take generations to unpack. And in that acceptance, there is a kind of peace. A peace that comes from recognizing that you live in a universe far more wonderful than you can fully comprehend. Your body is growing heavy now. Your thoughts are slowing. Your breathing is becoming deeper, more rhythmic. And somewhere in the distance, the universe continues its endless expansion, carrying ancient light toward our instruments, revealing mysteries that have waited 13 billion years to be discovered. There is a question that has haunted philosophers for thousands of years, and it remains just as mysterious today, even as we're armed with telescopes and computers and mathematical models far beyond what any ancient thinker could have imagined. The question is this: why does anything exist at all? Why is there something rather than nothing? The James Webb, in its own way, has brought us face to face with this question again. Not directly, mind you. The James Webb is a scientific instrument. It collects data. It measures light. It produces images. But the discoveries it has made, the mysteries it has unveiled, they all point toward something deeper. Something that sits underneath all the measurements and data and calculations. Something that suggests the universe is fundamentally different from what we thought. Let me tell you about structure. And I want you to really think about this, to let it sink into your bones, because this is at the heart of everything we're discussing. Structure is everywhere. It's in your body, the intricate arrangement of cells, the precise folding of proteins, the miraculous organization that allows billions of atoms to come together and form a conscious being. It's in the natural world, the spiral of a nautilus shell, the branching of a tree, the pattern of a snowflake. And it's in the universe, the arrangement of atoms into stars, the organization of stars into galaxies, the vast networks of galaxies stretching across billions of light years. And here's what's truly strange. This structure is improbable. It's statistically unlikely. If you took all the matter in the universe and threw it randomly into space, the odds of it organizing itself into stars and galaxies and consciousness is so infinitesimally small that we have to use special mathematical notation to express it. The probability is so close to zero that we might as well call it zero. And yet, here we are. Here is this structure. Here is this organization. Here is this universe, full of form and pattern and intricate complexity. Now, the standard answer that physics provides is entropy, the second law of thermodynamics. The idea that the universe tends toward disorder, toward chaos, toward maximum entropy. And locally, within our galaxy, we can create pockets of order. We can create structure. But we're doing it by expending energy, by burning fuel, by moving entropy elsewhere. But here's what's interesting, and this is where the James Webb's discoveries echo. In the early universe, when everything was hot and dense and chaotic, how did any structure emerge at all? How did the first galaxies form? How did order arise from what should have been almost complete chaos? The answer we've traditionally given is that it happened slowly. It happened gradually. Over billions of years, tiny imperfections in the distribution of matter were amplified by gravity. Small became large. Disorder became order. But we had a timeline for this, a specific amount of time available. And the James Webb has shown us structures that seem to have formed too quickly, that seem to have organized themselves more efficiently than our models allow. And maybe, just maybe, this suggests something about the universe that we haven't fully grasped yet. Maybe it suggests that there are mechanisms we don't understand, processes we haven't discovered, ways that the universe can organize itself that go beyond what our current physics can explain. Now, we should be careful here. We should be careful not to fall into mysticism. We should be careful not to invoke unknown forces or hidden mechanisms without evidence. But we should also be open to the possibility that reality is more complex than we realize. Think about it like this. If a child looked at a flower and asked, "How did this flower become so organized? How did it create such beautiful patterns?" An adult might explain photosynthesis, genetics, evolution. These are real mechanistic explanations, but they all assume an underlying structure, the structure of DNA, the structure of chemistry, the structure of physics. And if you keep asking why, if you keep demanding to know the ultimate source of order, you eventually reach questions that science, at least in its current form, can't answer. The universe, it seems, has a preference for structure, for organization, for pattern, and we don't fully understand why. We have mathematical descriptions of how structure emerges, but not why structure should emerge in the first place. Not why there is this fundamental propensity in the universe toward complexity and organization. The James Webb hasn't answered this question, of course. It's far too deep, far too philosophical. But its discoveries have made the question more pressing. They've shown us that the universe is even more structured, even more organized, even more filled with order than we realized. And that makes the mystery even more profound. Imagine you're walking through a forest at night, a very deep forest. The darkness is almost complete, but your eyes have adjusted somewhat, and you can make out shapes, trees, shadows, the vague outline of a path. And you know that if you just keep walking, eventually you'll reach the edge of the forest. You'll see the stars. You'll find your way home. But now imagine that as you walk, you realize the forest is deeper than you thought, much deeper. For every step you take, for every clearing you reach, there's another darkness beyond it, another forest within the forest. And you begin to wonder if there's an end at all. You begin to wonder if you're walking deeper into complexity rather than toward clarity. That's where we are now in our understanding of the universe. The James Webb gave us a flashlight. It let us see further into the forest than ever before. But what we've discovered is not clarity. What we've discovered is depth, layer upon layer of mystery. But here's what I want to tell you, and I want you to hear this as you grow heavier, as your eyelids grow closer to closing. This is not a bad thing. This is not a failure of science. This is the very nature of reality revealing itself to be worthy of our attention. This is the universe saying, there is more here than you realized. There is more to learn. There is more to wonder about. And wonder, you see, is not the opposite of peace. Wonder and peace can exist together. You can be filled with curiosity about something and simultaneously feel calm about not having all the answers. You can be in the presence of mystery and feel safe because you are not alone. All of science, all of humanity, we're all here together, wondering, learning, gradually expanding our understanding of what we are and where we are and why we're here. Now let's talk about something that very few people think about, something that is perhaps even more mysterious than the galaxies themselves. Let's talk about what's in between. The universe is not densely packed with matter. It's not crowded and cluttered. In fact, it's quite the opposite. The universe is mostly empty. Space is vast, and the things in it, the galaxies, the stars, the planets, they're scattered throughout, separated by immense distances. Think about it. Our galaxy, the Milky Way, is a structure of incomprehensible size. It contains somewhere around 200 billion stars. Each star is surrounded by empty space. And our galaxy is just one galaxy among billions. And between our galaxy and the next nearest galaxy, there are millions of light years of empty space. Empty, dark, silent. And as you look deeper with the James Webb, as you probe further into the cosmic distances, you see more and more of this emptiness. You see that the universe is not densely packed with galaxies. Instead, it's a vast, sparse network. Galaxies are strung together like pearls on invisible strings, connected by the cosmic web of gravity. And the spaces between them are unimaginably empty. This darkness, this emptiness, it's actually the largest part of the universe. Not in terms of mass, but in terms of volume. Most of the universe is nothing. Most of space is empty. And yet, we call this empty space dark matter and dark energy, because even though it seems like nothing, it actually comprises most of the universe's content. Dark matter, we can't see it. We can't directly detect it. We only know it exists because of its gravitational effects. Because galaxies move in ways that don't make sense unless there's a huge amount of invisible matter surrounding them. And dark energy, that even more mysterious substance, seems to be accelerating the expansion of the universe, pushing galaxies farther apart, making the universe expand faster and faster. Together, dark matter and dark energy make up about 95% of the universe. 95%. Which means that everything we can see, every star, every planet, every galaxy, every atom in your body, all of that makes up only about 5% of the universe. Imagine that. Imagine living in a world where the vast majority of the substance is invisible to you, where most of what's happening is happening in a realm you can't access directly. You can infer its existence through subtle effects, through measurements and calculations, but you can't see it. You can't touch it. You can't directly observe it. And this is what we actually live in. This is the actual composition of the universe. We are a tiny minority, a marginal constituent of reality. Everything we can see, everything that's visible to our instruments, everything we've built our understanding of the universe around, it's all just the 5%. The tip of the iceberg, the visible foam on the surface of a vast, dark ocean. The James Webb hasn't revealed what dark matter and dark energy are. That mystery remains. But in looking at how galaxies form, in measuring how the universe expands, in detecting those ancient black holes that grew so impossibly fast, the James Webb has made these mysteries even more pressing. It's shown us that our understanding of how structure forms is incomplete, and that incomplete understanding might be due to our ignorance about dark matter and dark energy. So as we float here in the darkness, let me ask you to think about something. Think about all the darkness around you, all the empty space, all the invisible matter, all the unknown forces. Think about how much of reality exists beyond your perception, beyond your ability to directly observe. And then think about this. Does it scare you, or does it comfort you? Because I would argue that there's something deeply comforting about it. There's something beautiful about living in a universe that's so vast, so complex, so filled with mystery that even our most powerful instruments can barely scratch the surface of understanding it. It means you're not bored. It means there's always something new to discover. It means that reality is more interesting, more complex, more wondrous than you ever imagined. It means that every night you can look up at the stars and know that you're looking at something that nobody fully understands, that you're looking at a mystery. And mysteries, I think, are what make life worth living. They're what drive us to learn. They're what keep us humble. They're what remind us that we don't know everything, that we can't know everything, that reality is inherently beyond our complete comprehension. So let the darkness around you grow deeper. Let the mysteries multiply. Let your mind float in the uncertainty and find peace there, because peace isn't the absence of mystery. Peace is the acceptance of mystery. It's the letting go of the need to control and understand everything. It's the resting in the knowledge that you live in a universe that will always have more to reveal. Your breathing has slowed now. Your mind is drifting. You're somewhere between wakefulness and sleep, and in that threshold, you're beginning to understand something that the James Webb has taught us, that the universe is not threatening in its vastness and mystery. It's beautiful. It's magnificent. It's a gift. Think about what light is one more time. Think about it not as a physical phenomenon, not as an electromagnetic wave with a particular frequency and wavelength, but think about it as a messenger. Think about it as a carrier of information from the past. When light leaves a distant galaxy, it carries with it information about that galaxy. Information encoded in the wavelengths of light, in the intensity, in the subtle signatures of the elements present in that galaxy's stars. And that light travels through space for billions of years, crossing the vast emptiness, passing through clouds of dust, navigating the expanding universe, and eventually, by the most improbable chance, arriving at our instruments. And when we detect that light, we are receiving a message from the ancient past. We are reading a letter that was written billions of years ago. We are looking at the universe as it was when it was young, when it was still forming, when the structures we see today were just beginning to take shape. This is the profound gift that the James Webb gives us. It is a messenger from the past. It is a bridge between now and then. And the messages it's been receiving, they're beautiful, strange, confusing, wonderful. Every image that James Webb has released, every spectrum it has analyzed, every observation it has made is telling us something about how the universe works. And yes, sometimes those messages contradict what we expected. Yes, sometimes they force us to question our assumptions. But that's okay. That's actually what we want. We want reality to surprise us. We want the universe to teach us things we didn't already know. Because if the universe only confirmed what we already believed, then we wouldn't be learning anything. We'd just be seeing our own assumptions reflected back at us. But the James Webb hasn't done that. It's shown us galaxies where we didn't expect to find them. It's revealed complexity where we expected to find simplicity. It's forced us to expand our understanding, to deepen our knowledge, to become more humble about how much we actually know. And this process of being surprised by reality, of having your expectations overturned, of being forced to learn something new, this is the very essence of discovery. This is what it means to be a scientist, to be willing to be wrong, to be willing to have your understanding transformed. Think about how rare this is. Think about how many people go through life without ever having their fundamental understanding of the world challenged. They believe what they were taught. They stick with what they know. They don't venture into territory where they might discover that they've been wrong about something important. But scientists, and in a way, all of us, when we're truly curious, we embrace this. We seek out situations where we might be wrong. We ask questions we're not sure we can answer. We look into the darkness and say, "What's out there? What will I find if I really try to see?" And the James Webb has given us an extraordinary lens through which to ask those questions. It has given us a way to see so far, so deep, so far back in time, that we're confronting the very foundations of our understanding. And what it's showing us, again and again, is that the universe is stranger than we thought, more complex, more wondrous, more filled with hidden structure and secret organization. Slowly now, I want you to begin to imagine that you're approaching the end of a very long journey. You've traveled so far. You've seen so much. You've ventured into the deepest parts of the cosmos with the light of the James Webb as your guide. And now you're beginning to turn around. You're beginning to find your way home. But you're different now. You've been changed by what you've seen. You've been transformed by the mysteries you've encountered. And you carry with you, always, the knowledge that you live in a universe far more complex and beautiful than you ever imagined. Your eyes are heavy, so very heavy. The effort to keep them open is becoming greater and greater. Your body feels heavy too, weighted down by gravity, pulled towards sleep. And this is okay. This is natural. This is what happens when you've journeyed far and long, and now you're ready to rest. As we draw to the close of our journey, as we begin to settle back into the quietness from which we emerged, there is one final thing I want you to consider. The universe is old, impossibly old, and yet it is also young. In the grand scheme of things, in the context of how long the universe might exist, we are barely out of the beginning. We are in the first chapters of a story that may continue for trillions and trillions of years. The James Webb sees back in time, back to when the universe was a child, still learning, still forming, still discovering what it could become. And when it looks that far back, when it peers into those early epochs, it sees that even then, even when the universe was young, there was already complexity, already mystery, already a kind of order that suggests purpose, or at least suggests that the universe was never truly simple. Perhaps that is the most profound discovery of all. Not the specific galaxies, not the unexpected black holes, not the mysteries about expansion rates and dark matter, but rather the realization that mystery is fundamental, that the universe, at every level, at every epoch, is filled with questions we don't have answers to. And this is peaceful somehow. This is calming, because it means you don't have to understand everything. It means you can rest in not knowing. You can allow the mysteries to simply exist without demanding that you solve them all before you can sleep. Your breathing has become very deep now, very rhythmic, like waves on an ocean, in and out, in and out. The night is very quiet around you. The world has stilled. And somewhere far away, so far away that the light from it takes billions of years to reach you, the James Webb continues to collect light, continues to receive messages from the ancient past. But you don't have to think about that anymore. You can let it simply be. The stars above, all of them, they will continue to shine. The galaxies will continue to expand. The universe will continue to evolve. And you can rest. You can let your conscious mind release its grip. Let your awareness drift away like smoke. The universe is vast. It is mysterious. It is beautiful. And you are part of it. A small part. An infinitesimal part. A consciousness that arose from stardust. Capable of understanding stardust. Capable of reaching out across billions of light years to touch the ancient past. But here, now, in this moment, you don't need to reach anywhere. You can simply be, simply exist, simply rest. The light is fading now, not into darkness, but into a gentler, softer state, a state between dreaming and waking, a place where the boundaries dissolve, where the universe and consciousness meet, where the questions become less important than the peace you feel. In the darkness, there is no fear. In the darkness, there is only rest. In the darkness, there is the knowledge that you are safe, that you are part of something vast and eternal. And the universe, even in its strangeness, even in its mysteries, even in the things it hasn't yet revealed, the universe holds you. It contains you. It surrounds you. A James Webb will continue its work, gathering light, revealing secrets, expanding our understanding. But that is for tomorrow. That is for another time. For now, for this moment, simply rest